Alright, now continuing to the next part, we need to monitor the speed and the time travel. Now if we see the speed here, this is changing with the speed with this potentiometer. Now we can see the speed is 0 to 100%, and here we have the voltage 7.1, which is kind of 71% of the speed. So if you see here, if I reduce these values changing here, so if you want to show the speed in percentage, I can use this variable and I can multiply this by 10 and I have the speed in percentage. If you want to show the speed in meter per second, which I have shown here, so you can use, oh sorry, not here, this one, 0 meter per second. It's right now 0.8 meter per second, and you can see this is also changing. Oh sorry, this is the maximum speed, and there is the speed 0.3 meter per second. So you can see this is changing. 0.7, it's close to the maximum. So it's up to you which speed you want to read, in meter per second or in percentage. Okay, so I can show that in percentage, which is more convenient way to set the speed. Okay, so we know the tags. We have the speed in percentage, and this is our SCADA DB, function of SCADA DB. So let's open the SCADA DB. Now we have the speed coming here. Now we notice that our speed is in real, so I will change that to real. Now the speed, I will take this one. Okay, wait, let me just put the sign here. Speed in voltage. This is multiplied by 10. Simply you can write multiplication by 10 or multiplication by 10.0. So this was our speed status. Okay, now next is the time travel. If you see here, I have written time travel of box and conveyor, and where I'm getting this information. I am getting this information presently in my conveyor DB. So here we have the time travel. If I show you online, this is the time travel. So I will show you how this is coming. So if you see here, the box, time of box in the conveyor, before it drops down, I have my time which is updated. So let me just change the speed a little bit faster, so the time will be reduced. That's 4 seconds, 5.593 millisecond. So this time travel finds out for how much time the box was in conveyor. If you think it's a very important parameter you want to show in your SCADA screen, you can do that. So how you will get this parameter? Now this parameter time travel, if you see, I put it in the output of this conveyor FB. So this conveyor FB is in my main FB, main block. So this is a time travel. For that I need a tag, and I would like to, I can directly give it to my SCADA tag if I want, or I can put it in my DB in out and then I link it to the SCADA. That's also possible. So let's do it. The correct way is I should put this in my DB in out, because here all the tags are in DB in out, and then I will read from my DB in out. Okay, so in my DB in out it will be in the output. So that would be my UDT conveyor. So it's not a long process. I will just take another tag. So I will write time travel, and this is actually coming in time format. So this is a time format, and I have to DB in out should be recompiled. So here I have this time travel, and this I want to read in my SCADA. So here time travel. So this is my time. This will come later. We need a SCADA tag. Okay, now DB in out is coming in a time travel, and the unit of this, the data type is time here. If you see, time travel is time, and here I've took integer. Now I have to check if my SCADA supports time as an input. This you need to check before proceeding further. So if I see if I make a new tag, OPC tag, I need to check here the data type if it supports time. No, it just supports these one, byte, short, integer, long. Date time is a different format, so it doesn't support time. So what we can do is we can convert this time this time which is in seconds and milliseconds into just milliseconds, or into just seconds. I think it will be good if you do it in milliseconds. So we can convert this time into millisecond, and how we can do that. So let's see if we have this time travel here, and I will take here first my SCADA DB. So I will take it double int. So time travel is here. Take convert. We have unit in time. I need to see if it is possible. Doesn't show here. Let me see if I put time travel. If I multiply this, okay, let me see what does it read. What value does it give by default? Let's see that. So I will download it. Reinitialize. I also need to give this DB to the output. I forgot. Hold on a second. So the main block, we need to give this here. This I forgot. Now we download it again. Perfect. Now I want to monitor my SCADA DB. What does it read if we have here value in time? So let's start the process again. Reset. Forward. Start. So let's see that now. So time travel is okay. One more thing, this block, the SCADA block, I need to call it in my main because we are reading the information. So I need to make a network. SCADA read write, and let's call it here. Otherwise it will not read the value. Download it again. So you see there are so many things we need to take care when we are programming the PLC and linking with the SCADA. You have to make sure all the functions are being called and everything is working. So now if we see here, we are getting the value automatically in milliseconds. If you notice, 4 seconds 953 millisecond is 4953. Let's see when it changes. 4568. So we don't have to convert it, it's coming automatically. And the direction you can see 0, process is running, and that's the speed in percentage. So let's change something. Something is wrong. Okay, so I'm going to change the speed. So we see that we are getting the speed input, that's working. Direction is also coming, 1 is reverse, 0 is forward. Time travel, we also saw that, and the run command is also working. So we have our 4 parameters coming in our SCADA DB, which we wanted. Now the next step is we have to read the SCADA DB in this DB and link it here. That's it. So let's do that very quickly. Now the step was, before you link any DB to your SCADA, you have to make sure that DB should not be optimized access. So I will go to this property, remove this optimize access, click OK, and then I will download this one. This is the requirement of the Ignition SCADA. So in some SCADA you can do that without optimize access. You can do with optimize access. In that case we mention the name of the tag, but in this case of Ignition we mention the offset. So we are in this SCADA DB now. It's here. Let's link it here. Okay, now open the SCADA screen. The trial is expired, no problem, we will reinitialize it. So we have some tags here already, so I will not disturb these. I will make a new folder where I can do a new folder. Let's name it conveyor. Okay, now here we will make new tag, new OPC tag. Now we know that the name of the tag, let's call the first tag as operation. operation. This is enable, OPC tag, value is Boolean, OPC server, we know that, copy item path, paste it here, OPC item path. Now I need to check the name of PLC if I don't remember. Let me see another tag. No, this is 2 for the first. Siemens 1, okay, that's fine. So it was Siemens 1. Back to the tag. Here I write Siemens 1, and now we need to know the name of the number of dB. It's dB3 and it's 0.0. So it's dB3 comma x 0.0. That's my tag. Apply and OK. And this is showing red because our PLC, our SCADA is need to be reset. Now it's reset. So this tag is okay. So operation tags goes here. So right now it shows it's on because the motor is running. Okay. If I stop it, this should be off. Okay. You can also show operation stop or motor running, motor off. It's up to you. You can change the text, no problem. Similarly, direction. So I will just copy this tag. Then it will be more faster. Operation 1, let's call it direction. And the direction has an offset of 2.0. Okay. So 2.0, and if you notice, this is integer. This is not Boolean. 2.0. So we write I 2.0. Apply, and this is our integer. So integer, apply, okay. So this is our next tag, and let's put it direction here. So it's 0, it's forward. No problem. Reverse. Now it's reverse. Now it's forward. So we see, now we are getting the information. Now speed in percentage. Now speed in percentage is 4.0 and it's real. So another tag, I will just copy this one. Paste. Here, speed. It's float. Now I'm not sure if it's R for real. I need to check it. I don't remember by heart. No, this is not R. Maybe this is F. The syntax of speed, float. No. Okay, I need to check the proper syntax if you are taking floating value. So I will go to my SCADA ignition Siemens addressing. Pretty quick. We have the manual here. You can also see that because sometimes you don't remember. So for float, what do we have? Oh, it's complete real. I have to write. So we open it. Real 4.0. Now it's fine. So just drop it and drag it here. So we have the value of speed in percentage. Similarly, for the time travel, we have another tag. So I will copy this one, paste it here. Time travel. And this is, if you notice, a double integer, so 8.0. So here, double. And for double, let me cross check again. It's di, double int, okay? So di 8.0. Perfect. Apply and okay. So time travel. Okay, now this is in milliseconds, so I have to, if I'm showing in the meter, this range should be more. So let's make it 15,000. Oh, for 15,000, there is no way I can show it. It's too big. This is too big for that. So let's not take this time travel in this meter. It's better I can show that an LED display, so which should be fine. So we'll just put it here, and we have the time travel box. 8 seconds, 904 milliseconds. So this is a kind of coming in millisecond. Okay, so let's check our connections now. So everything is working now. Let's run the conveyor. So my speed is defined, my forward is defined. Let me reset it. Okay, now it's running. You can see that conveyor is running. This is my speed, 45% speed, and time travel of the box for this first pallet was 7.3 seconds. Operation is running, direction is forward, speed is given, and time travel is given. So we have these 4 values coming from Siemens PLC to our SCADA screen. Okay, this is pretty long video, but I hope you understand how we took these 4 tags. So these 2 tags are very important, speed and time travel. Based on that, we will make some analysis, which we will cover in the next videos. And one more thing, height of the boxes. Now the height of the box I am not calculating as of now, but I can take a sensor, which I will show you, and we can find out the height of the boxes as well. So that is also a part of this exercise. So see you soon in the next video where we will talk about the analytics. Bye.